Number 17, I'm asked to find cosine 2 theta equals 3/4. Well, 3/4 is not a common unit circle value. Now, if it said, square root of 3/2, that we'd be talking about a different issue. But just cosine 2 theta equals 3/4. So what I'm going to do is I'm going to do the multiple angle approach. So if theta lives in 0 to 360, 2 theta lives in, I'm doubling that, so 0 and 720. So that means I'm going to go around the unit circle twice. And so that's going to be what I call beta. And so I'm going to look at this as cosine beta equals 3/4. And then I want to use my calculator to find the arc cosine of 3/4. So I'm going to go do that. I'm just going to go to my calculator. Double check that it is in degree mode for this particular question, since we're talking about degrees. And then if I arc cosine that, I get 41.4. Okay, so we have to kind of think for a second. 41.4 in the first, or where else is cosine positive? And that would be in the second. And so to get that, then I want to take 360 minus the 41.4, and that's 318.6. Okay, but I want to go around the circle twice. So each of those two numbers I'm going to add 360 to. So this guy I get 678.6, and the 41.4 plus 360. I get 401.4. Okay, now, before I get too excited and say those are my 4 answers, remember that that was for beta, so 2 theta then equal to each one, so say 2 theta equals 41.4, I want to divide by 2. So I really want to go in and take each of those numbers and divide by 2. So 41.4, and again, this is all calculator. 20.7. All right, 200.7. 159.3. And last but not least, 339.3 degrees. And notice that all 4 of those are all less than 360. Okay, so then that brings us to number 18. Number 18 is another example of factoring. So I'm going to bring over that bring over the 3 cosine x. So 2 cosine squared x minus 3 cosine x plus 1 equals 0. And I want to factor that. It's got to be 1 and 1. And this time they both have to be negative. So I get cosine x equals 1/2, and cosine x equals 1. And let's see, so feels like we've done this so many times. Cosine is positive in the first and the fourth, and cosine equals 1 puts me right there. Okay, so my angles are 60. Make sure I remember in degree form here. 60, 300, and 0. All right, at number 19, especially with parabolas, the trick here is to write out the general form and then make it look like that so we can identify our proper components. Let's see, it's y minus k squared equals 4px minus h, where h and k are the vertex. Okay. Well, let's see. If I have y plus 2 squared, I want 4 times something, x plus 2. So what do I multiply 4 by to get negative 16? That would be negative 4. Which already kind of tells me some information about what my picture is supposed to look like. So our vertex, let's scroll down here, our vertex would be -2, -2, based around both the y and the x. So -2 right there. And let's see, the focal length being go down 4. So just probably stop and clarify here. We are looking at a y squared, so that's a left or right thing. And so since it's negative, that means I want to go towards the negative x-axis, the 4 units. So 1, 2, 3, 4. All right, so there's my vertex, there's my focus. My directrix would be back. So 1, 2, 3, 4. So it would be back right here. So let me write down these ordered pairs here. So the focus is that, what is that, -2, -2. Ooh, my graphing is wrong. Hold on. I just now caught all these sign error issues. Okay, so I got the right vertex, -2, -2. So there's my vertex, and I'm going 4, so 1, 2, 3, 4. So if I go 4 out, that's got to be at -6, -2. And directrix has got to be back here, so 1, 2, 3, 4 is right there. So that's at x equals 2. And then the graph, so this is going to be kind of hard to fit on this little tiny grid here. But the lattice rectum has us go from the focus to the directrix length perpendicular to the focus. So that's 8 units. So I don't know if I can get 8 in here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I am way up here, and I'm way off down there off the screen. So we're just going to have to get this much of it. Okay, so that's what my parabola would look like. Okay, number 20. Find an equation for an ellipse given the following information. Well, let's see. So if the foci is at 2, 0, 2, 0, and 2, -6. Okay. And the length of the major. Okay, so what I can do is I can go halfway in between these 2 points, and that should be my center. So what is that? 1, 2, 3, 1, 2, 3. Okay, so my center has got to be right there. So my center then would be at 2, -3. Okay, so already I can write up part of my equation, because I know the x part has to be x minus 2 squared, and the y part has to be y plus 3 squared. And I also know, because they told me that the major axis is 10, so that means from the center I've got to go up 5 and down 5. So 1, 2, 3, 4, 5. So there's one of my vertices. And the other one, 1, 2, 3, 1, 2, 3, 4, 5 is right there. Okay, so that means I got to go 5 up and 5 down. So that means the major axis is underneath the y coordinate, and that would be 25 that goes down there. And so I can use the focal length, and I can use the 25 to figure out the other number, because it's focal length squared equals big squared minus small squared. And the focal length, let's see, focal length is up 3, down 3. So the focal length is 3 squared equals 5 squared minus the small squared. And so let me swap out that. So that means the small number squared is 25 minus 9. So that would be 16. Okay, so that's the number that goes underneath that. So that means from my center I want to go left and right 4. So 1, 2, 3, 4. 1, 2, 3, 4. And then I can sketch a curve connecting all of those points. And there you go. First task in 21 is to get it to put it into correct form, so I need to divide by 36. And so I get x minus 2 squared over 9 plus y minus 1 squared over 4 equals 1. Okay, so first task, let's find the center. And the center is going to be looking at the parentheses, and it's just opposite of what I see. So the x part is 2, so it's 2 comma 1 is my center. And it's bigger in the x direction, and it looks like in the x direction I'm adding 3 and subtracting 3. So if I look at the x coordinate, 2 plus 3 and 2 minus 3, I get 5 and negative 1, so that's going to be my vertices. So I get 5, 1, and negative 1, 1. Foci. So foci I want to, let's see, c squared is 9 minus 4, so subtract and get 5. So c would be plus or minus the square root of 5. And again, that's based off the center. So you got to think, if you're plotting point, you're starting at the center, you're going left and right to define all of these things. So it would be 2 plus the square root of 5 comma 1 and 2 minus the square root of 5 comma 1 would define our foci. All right, number 22. Okay, first thing is to group the x's and the y's together and then move that 41 over. So x squared plus 6x and minus 25y squared plus 50 all equals 41. Let's see, the x's are fine. I can go ahead and do factor by or completing the square there. The other number I do want to factor out the 25. Get y squared minus 2. I'm going to drop the y. Equals 41. Let's see, so 6 over 2 is 3, 3 squared is 9, so I'm going to add 9 to both sides. Then negative 25 over 2 is negative 1, negative 1 squared is 1, so I'm going to add 1. Even though I added 1, I really subtracted 25, so I got to subtract 25 from both sides, which then gives us, in factored form, x plus 3 squared minus 25 times y minus 1 squared equals 25. And then I want to divide everybody by 25. So our equation ends up looking like okay, so we get x plus 3 squared over 25 minus y minus 1 squared over 1 equals 1. Okay, so our center is going to be at, I'm looking at these squared pieces, so it's going to be negative 3 comma 1. So let me plot that, negative 3 comma 1 right there. And then I'm going to go left and right. So 25 says go left and right 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 right there. I go up 1, down 1. And that's where I'm going to sketch in my graphing box. And then I want to connect the corners with asymptotes. Okay. And lastly is actually put the curve in, which is what I was actually set out to do. And since the x is the positive fraction, that means it's a left to right one. So the green piece is actually our hyperbola. Okay, number 23, and I get to fess up. We're missing a number, and without the number, we can't really work it out. So I'm going to make up a number. I'm just going to say 84. I just picked a number. Okay, so first task then is to find the missing angle. Now that we actually can do this question. So 180 minus 70 minus 52. Now this is clearly a calculator question, so please don't think this is something I expect you to do in your head. So 180 minus 70 minus 52, and I get 58. So this angle up here is 58 degrees. So it's sine of 58 over 84 equals sine of 52 over x. So that's law of sine, so you want to cross multiply and then divide. So 84 times the sine of 52, and then take that and divide that by the sine of 58. And I get that x is 78.05. And that's perfectly fine. Okay, number 24, we've got two different triangles, both emphasizing a different set of skills. So I'm going to start by drawing a very generic triangle. So A, B, and C, and it says A is 22, C is 19, and angle C is 21. Okay, so my first task is to solve for angle A. I'm going to make my list. I want angle A, angle B, and I want side B when all said and done. Okay, so law of sines. Sine of 21 degrees over 19 equals sine of angle A over 22. And so I'm going to cross multiply and divide here. 22 times the sine of 21 divided by 19. And then I'm going to arc sine that. And so I get that A is 24.5. Now, because I used the law of sines, I need to double check that its supplement also isn't a valid answer. So if I do 180 minus 24.5, I get 155.48. And so that's my next question then. Can 155 and 21 degrees coexist in this picture? And that's a big yes. Yeah, you get, if you add those two together, you get 176. So I actually have two triangles with different angle A's. One triangle where it's 24.5 degrees, and the other triangle where it's 155.48 degrees. Okay, so now I'm going to go solve those two independent of each other. And maybe I want to draw another picture with my second numbers in there so I can see it myself. 155, and this one is 24. Okay, so then I want to take the angle C's, the 21 degrees, and then the other two. So let's take 24.5 plus 21, and let's subtract that from 180. So for that triangle, I get 134.5 degrees. And do the same thing for the 155. So that I get a very tiny angle of 3.52 degrees. And in both cases, I want to go ahead and use law of sines. Let's see, so that would be sine of, I want B, opposite it, so sine of angle B. Okay, so I want to cross multiply. So 22 times the sine of B, so I'll do the 134 one first, divided by the sine of A, okay, so in that triangle I get 37.8, and in the other triangle, okay, so sine of B times 22 divided by the sine of A. Okay, and then that triangle I get 3.25, so I get a little tiny angle. But you do want to watch for, it's called the ambiguous case with law of sines.